Hey monkeys, it's Jim from Small Time Outlaws, bringing you the 6th video in the Simple Game Programming Tutorial series. Now if you're like me, you're getting really tired of our little green dude just ignoring the floors like he's some kind of bala. So well, that ends today, my friends. In this video we're going to enable collision. Now because this game is so simple, I wanted to make this collision method as simple as possible, and it's not really, might not be the best method, but it works, and that's what's important. So going into our following module, we're going to, and into our player class, we're going to create some more fields. And these fields are going to be 2D vectors that hold the position of each corner of the rectangle that our player occupies in space. So you have the center position, and then going around it, we're going to have 4 points around that center position. And we're going to be checking each of these points to see if they're inside a tile that has a block in it or not. So starting out, we're just going to initialize them all. I'm just going to go with top left, top right, bottom left, bottom right. Initialize them all with empty or 0, 0 vec2ds. And we're going to create a new method, and this method is going to update these values every time we change the position of our player. So we're going to call it update corner points for simplicity. And for each one, we're going to say top left dot set, and we're going to set this to the player's position. And then because this is top left, we want to go back in the X direction to the left, half of the player's width. So we'll say player width, and it helps if I actually add this player width constant. So we'll do that after this. And we'll say position.y. Since we're going top, we want to go up in the y direction, half of the player's height. So that'll give us that top left corner. And now I'm going to copy this and I'll copy this part, and then I'll say top right is that, and we'll change this because we want to go over to the right side, so the X position plus half of the player width. Then we'll space this down, say bottom left, and paste. The bottom left is going to be left but bottom, so we're going to add half of the player's height to the Y position, and then then bottom right, we're going to add in both. So this is going to go over and down. And now I'm going to go ahead and up here in our constants, we're going to add the player width and the player height. So you can easily change this collision rectangle. Right now I'm going to make it kind of big, but you can go back and change it if you want it to be smaller, maybe smaller in the width so they fall off the ledge sooner or whatever. You can do that here. And I'm just make it 32 by 32, which I believe is what I set the size of our rectangle to, right? Yeah. Okay, and now we're going to create create a method, because instead of like every time we set this position, because when we reset we set the position, and then when we update we set the position, we're going to be setting the position in other ways. And every time we do that, we need to call update corner points. So instead of putting update corner points here and then putting update corner points here and everywhere, we're just going to create a method that we're going to call, instead of manually setting these, we're going to create a few methods. First one's going to be set position, and then it's going to take the X and Y value and set the position of our player to the X and Y value coming in, and then it's going to call update corner points automatically. So basically every time we call set position, it's going to set it and then call that. And then we're going to create 2 more just to make it a little easier, because there's times where we're only going to set the X position and the Y. So we're going to have one for setting just the X position, set X position, pass in the X value, and we're going to call set position. So it's going to call this one, but it's just going to pass the X that's coming in, and then it's going to use its current Y position. And then we're going to do the same for the Y. Set Y position of our player with a Y value, and then set it with the current X and the Y, new Y coming in. And that will do it for the player class. So let's go back into our main file, create a field, and what this field is going to be, it's going to be a map of integer arrays. And each of these integer arrays are going to store a 0 or a 1 for each generated row in our game. And the 0 is going to mean there's a block there, and a 1 is going to mean, or a 0 is going to mean there's no block there, and a 1 is going to mean there is a block there. So that's how we're going to simplify this pretty significantly. So we're going to call it collision map, and it's going to be an int map. This, again, this is one that comes with monkey, and it's going to be, so we're going to be mapping the row that this floor was created in with an array for that row, for each tile in that row. And basically this is just to kind of make it a little easier to have this game pretty much go on forever without having to create a two-dimensional array that you have to resize every time you want to add a map, and you're going to have a bunch of empty data in there too, because you're not going to have a floor on every row. So I'm using a map, and it works. That's the most important thing, right? As long as it works, and it works, it works. So now let's go back into our generate floor. See if I can find generate floor. So what we're going to do for each floor we add, we're going to create a new array of integers, and this is what we're going to be adding to our collision map. And these are the size of these integers is going to be the width of our map. So we're going to use our map width variable. And then these are going to, by default, in Monkey, when you create arrays, they're going to be all the values are going to be 0. So we're going to have 13 zeros here. So we need to go into, when we create the block, we need to set this block, and we're going to get the index from this value here, this X. So we're going to set the position in our collision array at this point, or this index, to 1. And that's going to specify, hey, there's a block here, so you need to collide with it. And then once we're done with that, we're going to add this array to our collision map using the set method, and we're going to add it at, so we're going to map this row value to this array, so I'm going to call array, our collision array, and that takes care of generation. And now, so for the actual collision, let's go say down here at the bottom, we're going to add a couple more methods. One method that's going to be useful is we're going to using a point in 2D space, or a pixel point, we're going to calculate the tile that that point is in. So this is how we're going to figure out which tile each corner of our player's rectangle is in. So say get, we're going to call it get tile from point, and this is going to return the integer version of our vec2d class, because we need to use its x and y values to specify the row and an index in an array. You can't use floats for indexes. Well, maybe you can in Monkey, but this is good practice if you're going to use languages other than Monkey. So we're going to bring in a 2D point in point in 2D space, and then we're going to grab the tile x value. And so the way we're going to calculate this tile x is the x position that's coming in is never going to be less than our map offset, because our player's never going to go that far, but our map tile x starts after that offset, so we need to subtract the offset from the position coming in. So at a minimum, let's say right now, I think the offset after in this map, or in the game right now, the offset is 8, and so the minimum value we're going to get from here, from our players, let's say the top left corner, minimum value we'll ever get is 8. So it's going to be 8 minus the offset, which will be 0, and then we're going to divide by the tile width, and that'll give us which tile is in the x direction. So in this case, if it's 8, then it's going to be 8 minus 8, which will be 0, divided by tile width, which will be 0. So it's going to be the 0, in the 0 column, the first column. And then it's kind of the same thing for the y, except we don't have an offset in the y, so you just do the y minus, or y divided by the tile height, and then that'll give us which tile it is in the y direction. And then we're going to return a new instance of our integer vec2d with those two values. So that's that one. And now for the next one, what we're going to do is, using this tile and the player's position, we want to calculate, first of all, we want to calculate if this tile is has a block in it, then we want to calculate the distance between the player and that tile. And this is how we're going to decide if they're above the tile or on the side of the tile. So we're going to call this get tile collision, and what it's going to return is a vec2d of the float variety, and what it's going to receive is the player position, which is a vec2d, and the tile we're checking, and that's of course the integer, the vec2di. Close that. And now in here, what we're going to do is we want to first grab the array from our map for this tile, or for this row that we're checking. So we're going to create a local array call of int type, and it's going to be the collision map, then use get, and then we're going to use tile.y. And what will happen here, we're either going to get an actual array or we're going to get an empty array back. So what we need to do, like say if we're checking a tile that's completely empty, doesn't have a floor in it, then we need to make sure we know we're doing that before we go on and try to check individual tiles in that array, because they don't exist. So the first thing you want to do is check to make sure the length of this array we get back from this collision map.get is greater than 0. So it means it actually has something in it. And otherwise, we're going to return null as our vec2d, and then we're going to check if it's null. Okay, then we'll say, hey, there's nothing there, so that's good. So now we're going to check if the tile in this array has a block in it. So we'll say tile.x equals 1. So this is in our collision map, remember our collision array, we set to 0s and 1s. If there is one in there, if it's 1, we want to grab the x distance, which will be the absolute value of this player position, and then minus, what we're getting here is the tile position, and not the actual not the tile position, but the tile value. So between 0 and 12 across, and then however many up above. But we need the actual pixel position of the center of the tile, so we need to do more math. And instead of typing through it, I'm just gonna go ahead and pause the video, throw it up there, and then I'll explain it after it's up. Okay, so for the x distance, what I did is I got the player position, which is an actual position in 2D space. Then I converted this tile x, this column value, into a point in 2D space by adding that offset. If you remember from before, the map offset plus the half of a tile to get the center of the far left tile, and then the tile value in the x direction times the width of the tile to get the value in the x direction in pixels instead of in tiles. And then I did the same thing with the y, the player position minus, and then converted using the plus tile height divided by 2 offset. And then I just returned a new vector 2D with those distances inside. And then what we want to do is close this off. Actually, I'm going to change this up. So now anything else is going to return null. Okay. Now let's go. We're gonna change things up just a little bit. What we're gonna be doing is we're going to update our player's position, and then we're gonna do all this collision checking. So I actually want to put this, instead of adding all these collision checks into our onUpdate method and cluttering it up, we're going to actually replace this player1.update with a new method call. We'll just call it update player, and then we're going to pass in which player we want to update, because eventually we're going to have multiple players, and this makes it a lot easier to, just send in a different player and then update it. And so we'll kind of separate everything out, clean it up, new method, update player, takes in a player of the player type. I don't know how many times I can say player. And the first thing we'll do is we're going to update the player so we get all new positions for its corners. And then a basic check we're going to do is make sure it's not going off either side of the map. So we're going to set the check for its left side, make sure it's not less than the offset, and you can use whichever left, either top left or bottom left, doesn't matter. Their X values are going to be the same. And we're going to set it to be less than, okay, so map offset. So if it's less than, remember that map offset, that black gap on the left side? If it's less than that, we're just going to set the X position of our player, X position, to be the map offset, plus we got to make sure we add, because it's centered, we need to add the player width divided by 2 to center it. And then check else if the right side of the player is greater than or equal to we need to check the left side of our map, so we need to do the map offset, then we need to add the width, the actual size of our map in the X directions, which will be the width. So every tile multiplied by the width of each tile. So if it's greater than that, then we're going to say, hey, you're too far, so we're going to jump it back in the X direction and set it to this value we checked. So copy and paste, and then subtract the player width divided by 2 to center it back. And I'll just make sure our left and right collision checking is working. We'll go ahead and run it and see if it's, oh, whoa, what was that? Okay, we got a problem here. Set the X position. Oh, whoops, okay. I need to actually, okay. So we need to call set position here so it actually updates it correctly. So we need to set it position to the, add our velocity, and then we're going to add it velocity in the Y here. So updates our position this way, that way we call update corner points. And we want to do that here as well, so it updates corner points when we reset. So let's say set position, and then it's going to set position to the original positions. Okay. Alright, this should work now. What? Oh, okay, whoops. Don't need to reassign because I'm assigning those inside the function. Okay, so this should work now. Whoops. Alright. Oh. Alright, make sure you spell correctly. Okay, it's gotta work this time. Okay, and reset. Oh, okay, so we're not moving fast enough to be able to see if that's actually working. I can't reach the side. So let's just change our player speed real fast just to make sure it's working. So we'll change this to 6. I'll run it. And there you can see we hit the wall, Cool. So that works. Boom, boom, boom. Alright, now for the fun part, actually colliding with our blocks. So first thing we want to do is store the tile that each corner point is in. So okay, start with the top left tile. Let's make an integer vec2d, and we're going to call our get tile from point function from before that we created. And we're going to use the top left in this one. So player.topleft x and player.topleft y. And then I'm going to use the magical coding fairy. Yada! So you can see all I did was just said top right, top bottom left, bottom right, bottom right. And now that we have the tile, we need to get the collision distance for each of these. So the way we're going to do that is, guess what? Coding fairy. Whoa, whoa! So you can see here I just took you call our get tile collision method, passed in the player position, current player position, and then each tile that we stored here. So top left, bottom right, and then created 2D float vectors for each one and called them call instead of tile. So now we have each tile and each distance, and some of these might be null, and so now we're going to check if they're null. That means there is no block there, so we don't need to check it for collision. So the first one we'll check, and you kind of want to, at this point we kind of want to decide which is more important. Do we want to check if they're falling onto something or falling, sliding into left or right? And in this case, this is a falling game, so we want to make sure at the very least they don't fall through blocks, because that would be very bad. So we're going to check the bottom ones first. So I'm going to say if the bottom left collision does not equal null, so this will tell us, hey, this one actually had a tile in it, or actually had a block. And now we'll say, now we're going to check if the distance that we got back in the x direction is greater than the y direction. Now that means the player is sliding left and right into this tile. Because I can show you kind of a little picture here. So you can see here, when the player is on top of a block, this x distance that we got back from our get tile collision method, the x distance is smaller than the y distance because it's up here. So there's a distance from the center of this block to the center of this block in the x, so from here to here, and then the y from here to here. So you can see that's a lot bigger, and it's always be bigger. They're going to be equal when you're right here, but it's easy to just say if they're equal when it's right on the corner, they're the same distance. You can just say, okay, well we'll make that a top collision, so we'll say up on top. And you can see with this one, when it's coming and it's colliding into the side, the y distance from the center to this center is a lot smaller than the x distance, and so that's how you say, okay, they're coming into it, or they're on the side, so we're going to pop them off to the side instead of on top. Alright, so let's get back into the game. And so for the bottom, we're going to check if that x distance on the bottom left is greater than the y distance. And we're going to set the player's x position and then bump it out of the tile. And guess what? There's a lot of code here, and so we're going to call upon the code fairies once again. Because I really don't want to bore you with type, and you can just, you can pause it and type it all up, and I'm just going to explain everything. So here we go, code fairy. Ta-da-da. So here we have our x position, so it's offset, using our map offset. Then we're grabbing that tile's left side, which would be right here. So the tile number, tile column, times the tile width. So that'll give us our left side. But we're checking the left collision, so we're going into a tile, so we need to bump them off the total width of the tile, and then center the player after that over to the right half of the size. And you can say here anything else. So this is going to be if it's less than, or if y is greater than x, or if they're equal, then we're going to say, okay, it was a top collision. So we're going to first set the velocity to 0 to reset it, to reset the gravity and everything. And then we'll set the y position to the top of that tile right here, and then we're going to subtract the player height divided by 2 to center it once again. And you can see the bottom right is pretty much the same thing. It's just you've got your bottom right switched out for bottom left, and then instead of instead of adding, you're actually going to take the side. This is the side of the tile, and you're just going to subtract the player width divided by 2 because you're going into it from the left, so you're going to bump it back out from the left side of that tile. And the Y is pretty much the same. And then you can see here, the top left and top right are a little less complex because, oops, I got a little extra N down here. Because in this game we're falling. There's no jumping, there's no going up, so we don't really need to check the top and bump them down if they run into from the bottom. So we're just going to check the top of the player if they're if as they're falling through, we don't want them to go through the tile as they're falling through, so they need to wait until they're all the way out of the tile, then they can go left and right. So that's what these do. They're pretty much the same as these. There's just no check because we're going to assume they're always coming into it from the side instead of from below. So go ahead and pause it, type this all out, and then once you're done typing this out, going to run this, and now you see our player is colliding, and so it might need to make it a little smaller because I need to slow the speed down too. It's kind of hard to squeeze in between those smaller gaps. But see, you can see all of our collision. Oh no! That must be too far. Oh, I forgot. Okay, so when our right side is greater than the right side or equal to, and if we set it to be equal to the right side of our map, that's actually going to bump us into the next column. So what we need to do is just bump it back 1 pixel. Now we won't go flying off into a bad index. And we're going to change this, our speed, back to 4 to slow it down so we can fall through the holes a little easier. So now we can do this, and we can slide onto that one, and there we go. Nice. And that's it for this long video. Hello, phone. Join me in the next one. I'm not sure what we're going to be doing in that one, but it's going to be fun. And eventually we're going to add graphics to this bad boy. Actually, I think that might be what we're doing in the next one. No, wait, no. Just trust me, it's good, whatever it is. And if you have any questions, email me at jim@smalltimeoutlaws.com or leave some comments down below. And see you in the next video.